Well, it's quiet, so I guess I better take advantage of that. Welcome, everyone. We're here to kick off the 9th annual Technology Showcase. This is one of my personal favorite events that we put on. Um, it's presented by the City of Mountain View together with the Mountain View Chamber of Commerce. And I'm the mayor. My name is Pat Showalter. And what makes this evening so unique is exactly what makes Mountain View so unique. We are the center of innovation for Silicon Valley. And that really makes us have a very special place on the world stage. Very small stage tonight, right? But still world stage. And we are one of the world's leading tech hubs, and we have a long history of world-renowned corporations, innovation pioneers, startups, tons of folks who love technology, like me, all engaging side by side. Mountain View is the innovation of epicenter, and it's amazing to discover the emerging technologies that are going on right underneath our noses. I hope you enjoy tonight's panel. And please come back tomorrow to see some of the exhibits and talk more closely to the scientists. And now I'm going to hand this over to my friend and colleague, the Chamber President and CEO, Peter Katz.
Thank you, Pat. Welcome, everyone. And I would be remiss if I didn't ask for the next slide to be displayed, because the showcase would not be possible without the support of our sponsors. So please join me in thanking our co-host, the City of Mountain View, our signature sponsor, Google, our partner sponsors, Aurora, Gaddick, LinkedIn, Waymo, the Mountain View Voice, and KMVT in the back there doing all the filming. This is being streamed. Being recorded so that others will be able to watch it later. And our supporting sponsors, Archer Aviation, Intuit, Lockheed Martin Space, Neuro, and Reliable Robotics. Can I have a round of applause for our sponsors? Thank you. As Pat said, we encourage you to check out many of our sponsors' displays, as well as many others, tomorrow right outside in the plaza. Really exciting things that are going to be shown. If I could have the next slide, please. So, to kick off tonight's event, we're thrilled to dive into an area of technology that's been going strong here for some time, but many people are less familiar with, unmanned airspace. There are several businesses here who've been operating for decades, and people will say, wait a minute, they're in Mountain View? And then there's other technology that goes on, people, wait, that's happening in Mountain View? Yes, it is. And so I really can't wait to hear what our panelists have to say about this. Our moderator tonight is Brian Kosinski. Many of you may know him as the Director of Leadership Mountain View, where he led the program for 3 amazing years. And, shameless plug, we are still taking applicants for the upcoming class. That's what the URL code is, or the QR code is up there in the corner. So for those of you who've never been through Leadership Mountain View, it's the most incredible way to get to know what makes this city tick and to build the best connections possible. We've had city council members, we've had CEOs, we've had storefronts, all of these people come to LMV. We invite you to as well. Brian did not, I'd like to think that Brian's life started at LMV, but it actually it was many, many decades before that. He was an aerospace veteran with over 32 years of government and commercial satellite experience, including working on a national asset spacecraft program while in the US Navy, and serving as Vice President of Mission Assurance at Space Systems Loral in Palo Alto. Did you know they were in Palo Alto? Okay. Brian remains a consultant for the aerospace industry. So we should be in for a fabulous flight tonight. And without further ado, let me welcome your pilot for the evening, Brian Kosinski.
Thank you, Peter, and welcome everybody. Might be a little bit formal for me wearing a tie tonight for a relaxed place like this, but my wife bought me this aerospace tie at the NASA Space Center, And every time I get an opportunity to wear it like this, gosh darn it, I'm going to wear it with pride. So Pat mentioned that right under our noses, amazing things are happening in Mountain View. Tonight, we're going to talk about amazing things happening above our noses in the sky. So let me start without further ado. I just want to introduce the 4 speakers and then give you a lay of the land for the next hour and a half. So Alex Norman is from Matternet, which does autonomous on-demand package delivery. Alex, yay.
Thank you. Pleasure to be here.
Jim Tighe from Wisk is the Chief Technology Officer at Wisk, which does autonomous electrical air taxis. Going to be an amazing presentation. And I have to say right off the bat, you win the award for the best company name, because when I watched your video and I talked about Wisk, it was like, yeah, that really makes sense.
Oh, our marketing people will be pleased.
Robert Rose from Reliable Robotics, which is automating all aircraft control systems. So thank you very much, Robert, for joining us.
Good to be here, thank you.
And Dr. Joey Rios from NASA is working on the air traffic control system of the future, because right now we have controllers that control airplanes, and what you're going to learn tonight, there's going to be things flying at different levels. They need to talk to each other, and it was amazing for me to learn that NASA has been working on this for a long time and putting some thought into this so that it will all operate safely. So thank you all.
Thanks for having me.
Okay, so each presenter is going to come to the podium and have 10 minutes to show some slides, and I believe each one has a video to show some of their operations as well. After that, I will get the creative juices going by asking some questions for the panel members, probably about 20 minutes, and then we'll open it up to everybody for about 30 minutes of Q&A from the audience. After that, there'll be networking in the lobby. So with that, I would like to bring Alex up, and I'll just tell you a little bit about Alex's background. Alex actually brought to commercial market the first drone autonomous package delivery to Switzerland in 2017. So I feel comfortable with somebody doing something here that has already been done and proven out. Alex has a master's degree in aerospace engineering and is an honored lecturer at French ENAC. Since I can't speak French, I will not try to pronounce the real name. So Alex, if you would come up, we'll advance the slides. Thank you.
Thank you very much, Brian, and thank you, everyone, for the opportunity here to speak. And it's a great pleasure for me to be here, and especially to this audience, because typically we're talking to people of the technical industry, and it's especially a special honor for me today to speak just for explaining what we're doing at Matternet and bringing it closer to the community, and also giving you a little insight into what we're doing here, maybe, as Brian said, also right under your noses in some way. So next slide, please. So what you saw there is what we're developing, which is a fully autonomous transportation network, something that you can rely on to send things back and forth, both directions, to and from these stations that you saw there. But we really started a long time ago, namely, around 10 years ago, with a problem that we discovered mainly in the global south. So basically, as you can imagine, in the global south, where infrastructure is not as built out as here, we were looking for solutions how to overcome, the absence of roads and basically bring urgent, especially medical goods, to communities out in places where they don't have access to all-season roads, especially. And with that, essentially, we conducted several tests and proof of concepts in the different regions, including Bhutan, Malawi, and Papua New Guinea, back in 2016. This image here was taken in Malawi, 2016. And from that place, we basically moved on and understood essentially we need to develop our system to a point where we can go back to these places and provide a fully autonomous transportation system that is affordable and can work to essentially bring all these necessary goods to people. Next slide, please. So we came back and realized basically that we have, due to completely different reasons, obviously, but we have similar problems in terms of getting things moved back and forth in and around our cities. And we have seen that, especially, there's studies around the fact that if we continue to, order more stuff on Amazon and, get more stuff delivered, we have to come up with smarter ways to move around our cities. And the 2D space essentially is not sufficient anymore. And especially if you think about small packages, all of you, I'm sure, know when you order food, for example, and small items, you're moving a 2-ton vehicle through the streets just to deliver a small package, essentially. So we think that there is opportunity for us to make this more efficient and also better for our planet, ultimately. Next slide, please. So we started in 2017 to deploy this technology over cities in Switzerland. We worked very closely there with the Federal Office for Civil Aviation in Switzerland to get that technology out, and we serve hospitals. We transport blood samples from emergency rooms to the labs, and like this enable a much faster turnaround and give doctors the opportunity to diagnose much more quickly than before, and are able to ultimately improve patient care in cities. And we have done this, what in the industry is called beyond visual line of sight. So that means there was no one involved that was looking at the airspace or looking at the aircraft. This was fully automated, and the aircraft flew between those locations fully automatically. Next slide, please. At Matternet, we don't just develop the aircraft itself. We develop everything that's needed around it. So you saw in the video the station, but then also we developed a cloud platform that is enabling all of that and kind of orchestrating that system to work together seamlessly. And we are also developing different methods to deliver the package or the payload. So you see here the tether drop. It's an ability for the aircraft to essentially hover at a certain altitude and then lower a package to any point in or any place where you need a delivery. So with that suite, essentially, we're able to transport things and create this network of matter. So really a transportation network for goods. Next slide, please. In order to do this, and in order to fly over cities and to fly in densely populated environments and also dense airspaces, we need to ensure that it's safe. And here we work very closely with the FAA, the Federal Aviation Authority, to really prove out the safety of our systems. And we have now become the only company that has a delivery drone that is certified by the FAA as a type certified aircraft. And that means essentially that it has gone through all that rigorous testing, everything from what you see here in the background, rain testing to vibration testing to endurance testing. Like there's a lot of testing that goes into proving out to the authorities that this aircraft is safe and it's safe to fly over over cities and people, and also in an airspace that is used. We're able to integrate the aircraft safely into the airspace, and our colleagues here I'm sure, will talk more about that as well. Next slide, please. Here you see, as an example in the background, an image of an aircraft in Zurich that is taking off from a hospital there, connecting it to another hospital and transporting urgent goods, especially blood samples. The way that we integrate aircraft into an already used airspace is also by use of very strict procedures. So it's not just the aircraft itself that is certified, but it's also the way that we do things that is certified. So the operation itself gets certified ultimately. And in Switzerland and in Europe, there's certain rules for that. And also here in the US, there's very specific rules that you might be hearing more about, which is called Part 107 and Part 135, rules that dictate how you can operate these type of devices. So it's really more, you can think of it more like an airline that's operating these devices rather than someone that's flying a small drone from the backyard. Next slide, please. You can imagine really that these, for example, stations may be deployed at different locations in the city or in front of restaurants, so people can access or even send goods and receive goods. Next slide, please. Or at a house where you can receive something, let's say food items or urgent goods that you need for maybe something that you forgot and you need for your kids. We can deliver basically safely to your home in a matter of minutes, essentially. Next slide, please. So all in all, we really striving to create this network that we can basically create a new layer of infrastructure in cities and communities that can rely on basically this new fast way to deliver things, both for healthcare, that's where we come from, where we really have gotten a lot of our experience in, and also for other items. Imagine you need urgent prescription or something, or you go to a hospital and they need to analyze your blood, getting that analyzed very quickly. So all these different use cases to really essentially raise up in a new layer of infrastructure. Next slide, please. And that's what we call the Matternet. It's the new layer of infrastructure. As you might know, the internet, the network of information, we believe that the Matternet will be the new network of matter to really connect people and deliver things back and forth. Thank you.
So our next speaker is Jim Tighe from Wisk. And Jim is the only person that I've ever heard of that is a winner of both the Collier Trophy, which is the U.S. National Aeronautics Association award for the greatest achievement in aeronautics, and also an X Prize winner. So pretty impressive. He has CTO experience at Kitty Hawk. He worked for Scaled Electronics and was involved in both the Spaceship One and Spaceship Two project, which is flying an aircraft, dropped from an aircraft into space and back, so pretty impressive stuff. And now he is the Chief Technology Officer at Wisk. While at Scaled Composites, Jim received a Design News Engineer Award and is an alumni from the University of Colorado. So welcome, Jim. Thank you.
Here, let me see if I can adjust this just a little bit. Okay, so everybody hear me okay? Awesome, thank you so much. Let me actually, there we go. Still good? Okay. Thank you, Peter. Thank you, Brian. Thank you, City of Mountain View. Thank you, Alex. That was amazing. It's great to learn a little bit more about Matternet and the awesome things that they're doing. And thank you, everybody here for coming out to learn a little bit more about what we're doing. Hopefully it'll be a lot of fun. So I'm here to talk a little bit about Wisk. So at Wisk, we're really about providing a transportation system to people. So in the same way Alex is trying to move things around an urban area, we're trying to give our customers a service where they can get to from where they are to where they want to go, perhaps a little bit easier and a little faster. So if you can go to the next slide or play this video. So the aircraft behind me, we call Core. It's our 5th generation aircraft. We've been flying for some time, and it's pretty fun for me because it's interesting to watch an airplane fly backwards and fly sideways and stop in the middle of the air and stop and turn around, and it's not what you would expect. But on the other hand, one of the greatest things about it is after watching it for a while, it becomes normal, almost, not for me, but maybe boring. And that's success, right? If you can picture something that you can envision as being part of your normal lives, a way where you can get to where you are to wherever you want to be, I think we're doing a great job. So this airplane and airplanes like it have flown, most of our flights have been in Ulster, which is about an hour south of here. We've also flown in New Zealand and done about 1,700 flights, and now we're working on our 6th generation airplane. Some of the flights we've done recently have included a flight demonstration at Oshkosh, which is actually the world's biggest air show in Wisconsin. It's going on right now. If you ever get a chance to go, I'd recommend it. It's pretty awesome. It's a lot of fun for airplane nerds like me. Well, I'll talk a little bit about it soon. But maybe next slide, please. So we really want to be the future of mobility. Just as, today you can take an Uber or a Lyft to the airport, wouldn't it be great to be able to take an air taxi to the airport? And instead of being stuck in traffic for an hour, fly a 15-minute flight and go to the secure side of the terminal perhaps and walk right onto the jetway and get on your airplane. How cool. Yeah, I think that's kind of sells itself, I hope. My wife and I, we live in San Jose, and can you imagine being able to go up to San Francisco, right, and see a concert or a show and come back that night and save a little bit of money on the babysitter, which probably we might pay for the flight. Next slide, please. So a little bit about us. The company was founded back in 2010 by Larry Page, who was one of the co-founders of Google, of course, and Alon Crow. And they recognized way back 14 years ago that cell technology, computer technology, aerodynamics technology, propulsion technology have all reached a point where air taxis are actually possible. And that great insight really led to the foundation of the company. Since then, we've grown. So the company is about 800 people right now. We've also now are a Boeing-backed company, which is pretty exciting to be part of the Boeing family. It's just been around for over 100 years and flies millions of people every day on the aircraft and has 10,000 aircraft in active service. They're really a natural partner to make this thing a reality because what we're trying to do is hard and really requires dedicated, persistent effort to make realized. So that's great. We're here in the Mountain View area, so our headquarters are very close to here by Shoreline Park, which is just an absolutely beautiful place to be. And we've been fortunate to be part of this sort of Bay Area community, but we're also a global company. So we have offices in New Zealand, Montreal, and Atlanta, and other folks throughout the Boeing organization who are really supporting our efforts and trying to make them real. So we have a couple of patents, and we've been lucky enough to do many flights over the years. So, the flight count right now is a little bit over 1,700 flights and growing of full-size aircraft. Of course, we do many more flights with subscale aircraft and in simulation. Next slide, please. So a little bit about our airplane family. So the company's kept a low profile. So I joined the company back in 2014, and when I went to my interview, I wasn't sure I was at the right place because there wasn't a sign out front. But since then, it's great to be able to share a little bit about what we've done over the past 14 years. Way back in 2014, we were flying airplanes, full cells airplanes, both here and at Edwards Air Force Base. And since then, we've flown piloted aircraft and autonomous aircraft. So most of our aircraft flights to date have been without a crew on board or a pilot on board, which is a really exciting opportunity because it enables us to provide a service at scale that's not limited by the availability of commercial transportation pilots, and also ultimately it will enable safety, which I'll talk about a little bit later. Next slide, please. So I think it's important to talk about people. We have this is just a small fraction of the people working on these projects, but I've been fortunate enough to work on some pretty exciting projects, and like the projects I did at Skeld and now the projects I'm doing at Wisk. And really, the reason for the success of those projects is the great team of folks that we have. So to make these things happen, you need to have a talented team of technicians, of engineers, of fabricators, of business people, and everybody working together really makes this happen. So I'm really proud of this team. Next slide. So I'm also excited about the airplane. So right now we're working on a Gen 6 airplane. So it's a bit bigger, has a bit more payload capacity, 4 people can fly in it, as opposed to the other one, which is a 2-place. It also has creature comforts like air conditioning, a place to put your bags, and automotive-like interior. So if you like your Tesla or your modern car, I think you'll be very comfortable in our aircraft. Next. So the key thing that you won't find in our aircraft is pilot controls. So I've given many presentations and tours of our facilities to various folks, and at the end of it, they always ask, so where's the pilot going to sit? Well, so one of the key takeaways today is there is no pilot. It's an autonomous aircraft, so there's no pilot control. So every seat is a passenger seat. So you can sit in the left seat and be very comfortable. The way I like to explain the service we're trying to operate is it's like a gondola. So picture going to a ski resort or a place where there's like an urban gondola, like in Portland, and you get in the gondola, and the gondola takes off and takes you where you want to go. We're doing the same thing. It's just with an airplane. So it's exciting. Next. So a little bit about what we're doing today. So right now we're in the middle of building our 6th generation aircraft, and so it's actually a really rewarding time for me as an engineer, because you get to see all these pieces that have been on a computer screen like come to reality, which is super cool. So this picture is actually taken in Philadelphia at a Boeing facility. That's the Boeing vertical wind tunnel facility. That's one of our propellers that's undergoing testing right now. So part of making a safe vehicle is doing lots and lots and lots and lots of testing. You test at the component level, like a propeller blade is an example. You test at the assembly level, like a full rotor. You test at a motor level, which is the motor plus the rotor. You test at the subassembly level, so the rotor plus the boom, and you test at the, on, and finally you get to the wing test. And that's how you're confident that it's going to work. It comes down to a lot of hard work and a lot of testing, and that's just a good example of it. Next slide. So that's a picture of Daniel. Daniel Reyes, he's a great systems test engineer, and he's there with one of our booms. So that's like what one of these flight structures look like. So it comes together because a lot of talented people like Daniel think very hard about what the requirements are, what the regulations are, what the load cases are, and build a structure, and then think about hard how to test it and make sure that it's successful and works every time. So just a cool piece of structure, and if you keep an eye on our website, wisk.aero, you're going to see a lot of neat stuff in the next couple of months. Next slide. So that's all I had today. I know we'll talk a bit more in the panel about how autonomy works and how we're going to integrate it into the aerospace system. But again, really thankful that you guys are here, and I appreciate your attention. So I'll turn it back to Brian.
Jim's a little taller than I am.
Oh, sorry about that.
That's all right. So it's rare in my experience to find an engineer with a sense of humor. So I kind of chuckled when you said we have a few patents and it was 280 on the screen. But maybe that wasn't a joke. Maybe he was just being humble. I'm not sure which, but thank you. Pretty impressive stuff. Next, we have Robert Rose from Reliable Robotics. And Robert has a deep experience in a lot of aerospace, self-driving car, and robotic spaces. So I have a question for the audience. How many people have seen a SpaceX Falcon 9 launch where they not only launch, but they re-land the first stage? Pretty cool stuff. So Robert was in charge of the first 10 Falcon 9 rocket launches. Just amazing stuff. Another show of hands from the audience. How many know that when we retired the space shuttle, we were dependent on the Russians to launch people and supplies to the space station? Right. Pretty embarrassing, right? Well, we were dependent on a commercial industry to solve that problem. And Robert was in charge of the first 5 Dragon spacecraft that went to the space station. So amazing stuff. Robert is also a fellow of the Royal Academy of Royal Aeronautical Society. He has multiple patents. He has a BS in computer science, a BS in computer engineering, and an MS in electrical and computer engineering from Oregon State. So please welcome Robert from Reliable.
Well, thank you for the introduction. I had a small role in Falcon 9 and Dragon, just a little bit of the software, but I appreciate it. Thank you for the opportunity to speak. Thank you for everyone for coming out, and I'm glad to hear from other colleagues local to Mountain View and to see what you guys are doing. So yeah, my name is Robert Rose, background in software engineering and safety critical systems development now for most of my career. Started this company here in Mountain View 7 years ago this week. It's our anniversary. Oh, thank you. Yeah, startup. We made it 7 years. Hopefully we'll go another 7. We started the company in my garage, which is overrated. Don't do it. I thought it was going to make for a great story, but it's really working in a garage. It's kind of like camping. We didn't have air conditioning, so when it's hot outside, it's even hotter in the garage. When it's cold outside, it's even colder in the garage. Your kids are running in and out, the dog's barking. I mean, it's nice that you're kind of working from home, but then all of your coworkers come to work from home with you. So it was a good day when we found this spot in Mountain View off of Ringstorf. We're not quite by the shoreline, not as glamorous, but we are closer to Costco, which has its pluses. Can we run the video next? Here we go. Okay, so we're about autonomous aviation. We're about retrofitting, or excuse me, upgrading existing aircraft with automation capabilities. This video is from a flight test that we performed late last year with a Cessna Caravan. This is a aircraft that's capable of carrying about 12 people in the passenger configuration, carries about 3,000 pounds in a cargo configuration. After many years of flight testing and development and getting approvals from the FAA, we reached a point where we were comfortable taking the pilot out of the cockpit and then operating this aircraft remotely. So this entire operation actually was flown from Mountain View, even though the aircraft was down at Hollister. We have a control center here right off of Ringstorf where the remote pilot was managing the operation. They don't have a joystick. There's no remote controlling. I react to calling it teleoperation. It's really more like remote programming of the aircraft. You're providing a flight plan and then uploading it to the aircraft over a satellite communications link. Aviation today is also largely driven through radio communications and pilots talking to other pilots and pilots talking to air traffic control. And we have the ability through the satellite communications link for the remote pilot to hear all of the same things, and they can push a button and record a message that's then streamed out to the aircraft. So really, surrounding aircraft have no idea that they're talking to somebody that's in a control station many miles away. You guys also operate out of Hollister too, and it's fun when people get on the radio and they go, "Hey, am I talking to a real person? Are you a robot?" No, it's a real person. This is not an AI voice. I'm a human being. I'm just not in the plane. And I think this speaks a lot to our vision for how to integrate aircraft. We started the company because we saw an opportunity as an incremental step to bring the world closer to autonomy by adding automation technology into the aircraft, but still keeping a human being involved. They're very much a pilot. They're certificated with all of the same approvals that are required to be a pilot in the aircraft. You're just not in the aircraft. A little bit of company history. I mentioned we started in 2017. That actually was not our first remotely piloted operation. We started out on a Cessna 172, which is a 4-passenger aircraft. We flew that with nobody on board back in 2019. Again, that was under FAA approval. What else to mention? We're now working on certifying this technology. Well, we've been working on certifying this technology for 7 years. Most significantly, earlier this year, We got the FAA to approve to all of the low-level certification plans involved with the first stage of our program. And this technology will enable an aircraft to operate without a pilot ever touching the controls. Key components of this, there's a navigation system that we've developed that's very new, that's higher precision, higher integrity than what goes into aircraft today. So for an example, you all have a GPS localization system inside your phone. I wouldn't trust my life to your phone, but if you take many different phones as well as other sensors and you fuse them together, then you can start to build a system that you can trust to localize your position. And we've got algorithms that we've developed and have identified with the FAA a path to get this technology certified. We've also worked with the FAA on how to automatically land aircraft at airports that do not have instrument landing systems. So if you're a pilot, you may have heard of ILS. We can land without ILS. It's pretty cool. We can also do automated takeoff, which is something that hasn't been certified before. And we can also do automated taxiing, which has not been certified before. Why don't we go to the next slide? This is more company history. We can keep going. Next slide. So how does the technology work? There's really three main components to this. Like to joke that to fly an autonomous aircraft, the first thing you need is an autonomous aircraft. And so for that, you need all of the technologies that I mentioned previously, and that's a key part of our certification activity with the FAA right now. The second thing you need to integrate this aircraft into the airspace. You're going to talk about the future of the airspace, but the reality of today is it's people talking to people. And so you need the communication system. You also need a detect and avoid system, which is the industry jargon for basically replacing human eyes looking out the windows and not hitting anything. We developed an in-house radar system. I'm actually really excited to show this to you. It's pretty cool. That looks out and scans around across the horizon. Can detect other aircraft intruders and then come up with a collision resolution path for the aircraft. And then the third thing that you need operational approval. So, if you're a private pilot flying for yourself and you're not getting paid, it's relatively straightforward to get in a plane and go fly. But once you're flying for revenue, the FAA takes a completely different view on regulations. As you know, you mentioned Part 135. The technical term for the federal regulations that control how revenue operations are operated. Something like that. So we have an airline that is running out of Albuquerque, New Mexico today. It's actually running routes on a regular basis for FedEx. And the third part of this, third leg of this stool, if you will, is getting the operational approval, which includes all of the maintenance procedures and inspection plans so that we can operate the equipment at scale. Okay, next slide. I think I already talked through this, so we can go to the next slide. I want to talk too briefly about the future of aviation. Although we have this incremental path, we do see a path to get eventually to a place where you don't need a human involved. And I want to be clear that I think this is far out in the future, but it will happen eventually, and we should be planning for it. And I'm really excited by the work that NASA and others are contributing to this effort. Our first step is to still have a pilot, but to have the pilot in a control center. The next step would be to have a pilot managing multiple aircraft simultaneously, much like air traffic control does today. And it's actually not one person managing multiple aircraft. It's a team of people managing a larger collection of aircraft. And to do that, we need to redesign the airspace. And so that's my setup for you, for your talk. And then eventually, once we have large sections of the airspace operating under these new rules, then I think we can start to expand that and then finally enforce it through regulation and congressional action to say that if you want to operate an aircraft in the skies of the United States, you have to be using these new digital communication systems. And only when that occurs will we have truly, fully legit autonomous aircraft operating. But I think it is a really exciting future. It's going to happen. And if you write your congressman or woman, Anna Eshoo, well, whoever's going to be the new one, let them know that they should be allocating funding towards this activity, because I think it's important the United States lead in this effort. Okay. Thank you very much for the opportunity. I look forward to the Q&A.
Thank you very much. Fascinating stuff. Congratulations for having the courage to offer your garage to such great work. Our next speaker is Dr. Joey Rios. Dr. Rios is the Chief Technology Officer, or Chief Technologist for the Aviation Systems Division at NASA Ames. There's some really cool stuff going on at NASA Ames. We just have so many gems in Mountain View, and NASA Ames is certainly one of them. So I appreciate you coming today. Dr. Rios has been working on the UAS traffic management system, which is, I think I could say, the control of the future for what you've been seeing in the last 3 presentations. He led a team that won the Software of the Year award for NASA for this work. And NASA is a really, really big place. So to win the Software of the Year award is, I imagine, a pretty big deal. So if those of you in the audience that say, I'd like to be a panel member next year, if you haven't won an award already, you have to go out and win an award, because it seems like everybody up here has won a couple awards. So Joey has a PhD in computer engineering from Santa Cruz and undergraduate degrees in computer science from Cal State. So welcome, and thank you very much for coming.
All right. Well, hello, everybody. Thanks for having me. Really appreciate the opportunity to talk about the things we're doing at NASA. And I really appreciate you putting me last, because we got to see different operators, different vehicles, and all of their thoughts about how they're going to be using the airspace now and in the near future and in the far future. So I'm going to talk a little bit about what we're doing to try and enable that. We had kind of a saying that was coined by one of our key researchers at NASA, PK, and he said that we want to make sure that the airspace is ready when the vehicles are ready. So you see these folks building these amazing machines. They have very specific use cases, very specific things they want to do to impact our lives. We don't want to have them get all the way down the line and then not being able to access the airspace and fly effectively and perform those use cases. So what we're really trying to do is make sure that we're ready for that. And it's been hinted at a couple times, but if you think about how air traffic works today, which a lot of us do up there, we spend all day thinking about that. You don't have to, but thinking about how we control traffic today, it is, folks, you see them in the movies, right? Sitting at a control station. They got their little screen in front of them. They're seeing the things move. They're talking to pilots via voice, letting them know where to go and how to separate. If you think about the scale that Wisk wants to do, you think about the automation that Reliable Robotics wants to have, you think about the different operating procedures for a small UAS at low altitude that Matternet is talking about, that paradigm doesn't work. We can't hire that many more controllers to watch every little drone in the sky, right? Everyone realizes there's a scaling problem in terms of air traffic control. So as these vehicles and these operations move towards more highly automated systems, the air traffic control systems need to move towards more high automation. One of the things that people wonder about is, why is NASA doing this, right? What is it? When I tell people I work for NASA, usually the first question, oh, cool, you build rockets, right? You build a cool rover on Mars. It's like, no, that A in the middle of NASA there is for aeronautics, right? We focus on aeronautics. And then the next question was, oh, cool, you're building like cool jets, like neat engines. Well, no, it's more like managing the traffic. And at that point, that's when they usually walk away disappointed. But it's important work, right? Because again, we want to enable this kind of stuff. I am not going to focus so much on the air taxis and the operations that Reliable Robotics are targeting right now. I'm going to focus on the small UAS and enabling those operations. And the reason being, they're happening at scale sooner. And the way in which we manage the traffic for these small little drones that are going to deliver packages, they're going to help perform public safety operations, the way we manage them and recognize how they access the airspace is going to lay the groundwork for how we automate the airspace for the larger aircraft. So we really want to solve that problem as best we can. Doesn't mean we're not working on all those problems. It just means that I'm going to talk right now about how we're doing it for small UAS. When I say UAS, it's a drone, UAS. So with that, I have a little video that was put together, just a minute and a half to kind of give an idea. So can we just roll that video, and then I'll talk again after that. All right, pretty good stuff. So you can see we're very focused on those issues in order to open up the skies like we're talking about there. And something I didn't mention is that we don't do this in a vacuum. We actively collaborate with industry and the FAA and local municipalities and everyone that may be having a stake in what we're doing. So we have agreements and partnerships with lots of folks like the ones you see up here on the panel with us. We work on things like specific technology for the vehicles, or we work on things like airspace access, or concept of operations, or flight testing collaboratively with other partners. We try and enable and facilitate that, again, to move the ball forward is really what we're doing. This is actually my last slide. It is a recent image from the past month. And I'd like to take a minute and kind of have you look at it and see what you notice, right? And I'll point out a few things that I think are cool and how it provides a good picture for us to talk to. So first of all, let's see, how many drones do we see? We've got 2 of them, right? They're actually not that far apart. So you'll see one in the foreground on the pad, getting ready to take off. That's owned by Manna, M-A-N-N-A. They're actually an Irish company that's beginning operations in the US. They have tens of thousands of deliveries to homes in Dublin, Ireland. Right, so they're actively, this is technology they've proved elsewhere. And the dream of a lot of these companies is to unlock the operations in the US, right? They see this as the cash cow, right? There's a lot of places to deliver, a lot of use cases, a lot of people ready to benefit from what they want to offer. Now the other drone, if you didn't notice it, is in the back, up in the sky. Okay, and it's heading in for a landing. This one's getting ready to take off, that one's landing. They're from 2 separate companies. They're about 30 feet or 30 yards apart, let's say at the most, 20 yards. That one back there is from Wing. Wing is one of those spinoffs from Google. Google's parent, they have the same company, parent company as Google from Alphabet, right? So Wing lives underneath them. And Wing is doing deliveries, for example, for Walmart right now. They're doing a lot of that in Texas currently, as well as other locations. This photo is taken in Texas. There's a lot of operators converging right now in that Dallas area to prove out these concepts. And actually, they don't like us to say that. They're not proving out the concepts. They're doing an operational evaluation of things we've tested over the past decade. And like we mentioned before, you can't manage these one by one, right? And how do you have multiple operators wanting to fly this close to each other and drop packages to neighbors, right, simultaneously? And while they're doing that, what happens if and when a police department has an operation they want to perform in that same neighborhood? Right now, there would be probably a lot of phone calls, right? Like, hey, I'm going to fly over here. Are you flying over there? Be aware I'm going to do this. That's not scalable, and they all recognize that. So what they do, and what you don't see in this picture, is how they're doing that coordination. It's a digital system in the back end. So this operator, Mana, they will share their intent. They're going to share what they're going to do in the airspace with that vehicle. And that digital exchange of information, again, it's not people calling each other. It's not voices over the radio. These are digital pieces of information sent over the internet to the other company, Wing, which would receive that intent from Mana and know what Mana is going to be doing. These automated systems can then say, hey, it looks like, at least at a strategic level, we know where we're each going to be. We're going to keep apart from each other. That's a good layer of safety for us. So this is being proved out in Dallas currently with 4, 5, 6, 7 companies, depending on how fast they mature. But these are real operations, real deliveries to backyards right now. And you saw Alex talking about Matternet earlier. It's something that a lot of folks are working towards, and they need to unlock the airspace owner to do it. And at NASA, we're trying to facilitate that. One thing I want to emphasize, again, something else you don't see here is the work we're doing to engage public safety operators. They're the most active users of the airspace right now that we're pointing at, right? These are actually the new entrants in that airspace, whereas police departments have been using that airspace for a long time, right? They'll send up a drone to overwatch a fire or to help support folks in a search and rescue. They'll be using the airspace quite a bit. So making sure they're integrated, their use cases are part of this. How do they exchange data? Can they participate? These are all important questions that we're trying to facilitate with us, the FAA, industry, all at the table. So again, I pointed out that this is laying the groundwork for how we access the airspace in the future. You saw Robert's kind of timeline for, we don't need to change the airspace yet, but at this point, if we want to get to the scale we want, the airspace needs to change. And that's going to be through services that are not human-based, right? It's going to be through procedures that are automated, data exchanges that are automated, and we're laying that groundwork here with the small UAS, these small drones right now. And I think that's the big message. Be looking forward to some questions and conversation, but appreciate the opportunity to talk about this.
Thank you very much. Okay, so I would like to start with a couple of questions, and then we'll turn it over to the audience for harder questions, perhaps. I don't know. So some of your companies have been started in Mountain View. Some have their headquarters in Mountain View. Some are global companies. But I'd like anybody who wants to volunteer. Why Mountain View? What is it about Mountain View that has you sitting here and being invited to do this talk? Any popcorn method? Want to go first?
Well, I can jump in. This was definitely a question for where to start this company when we got together. My co-founder, Jörg, was based in LA and decided to move up here to do it here. I think there's very few places in the world where you have aerospace engineering talent to have a company like ours. Most of them are in California, to be honest. You've got a big concentration in Los Angeles, San Diego, and here. I think many people underestimate the power of the Bay Area for aerospace and aeronautics engineering. A lot of it actually began around the World War II area here. And when I say one, I mean not just like computer engineering and computer science and mechanical and aerostructures, but also the technical know-how and the technician base to be able to build these types of
Absolutely
components.
important.
Requires an attention to detail that you don't find really in that many places in the world. But we were also a little biased by the weather. I like trees, and it rains up here. And if you've been to LA, it doesn't rain in LA. It's a little weird. And I like that it rains here, but not too much.
Awesome. Thank you. Anybody else want to tackle that?
Yeah, that with the weather is kind of a two-edged sword, because the first time we had a drone in Switzerland, we had to learn that the weather isn't so good everywhere in the world. Yeah, and then I think it's really like what's very interesting about this type of aerospace now, like the age we're coming into, is really this intersection of computer engineering and software, and the really old school hardware side of things a little bit, and I think this place here at the heart of Silicon Valley, really, that Mountain View is a great place for this type of talent, like really mixing these two.
I've been reminded by the experts in the control room that if everybody could speak into their mic, that would be helpful. Anybody else want to tackle that one, or should I move to the next question? Good. Okay. The next one is, and I'd actually like all four of you to answer this particular question. Some of them we don't need all four, but this one is I would like to know, although Joey, I'm not sure on your side, but the question is, what kinds of jobs will your technology introduce into Mountain View? A lot of people get scared that when you automate an aircraft, then you're putting a pilot out of a job. But what they don't understand probably is that that's creating other jobs. So not only the technicians and the software and that kind of stuff, but what is the spectrum of jobs that open up because of the groundbreaking technology that you're working on?
Yeah. Well, so I mean, the beauty of this is really that it's not just developing the systems and maintaining the systems, but also operating them and like really bringing them out in the field is like a whole end-to-end, and it opens up all sorts of places for talent, really. And if we talk about specifically, automating transportation, it's not so much, taking away jobs. It's more like making people more effective in what you can do. Like now, one person can deliver so much more in a given time period. So essentially, if you equip one person with a drone, they now can deliver so many more blood samples than they used to be able to, stuck on the 101 trying to get from one lab back to the hospital. So it's really just changing everything and giving us better, ultimately, a better outcome for people, better outcome for patient care, and ultimately, just changing the whole job situation.
Yeah, I guess, there are a couple different levels on the job side. I mean, pragmatically in the near term, I think collectively we all need a lot of different skill sets. So we have a lot of software engineers who develop the autonomy systems and the flight control systems and the motor control systems and the ground support systems. We have a lot of engineers, electrical engineers, mechanical engineers, structural engineers, aerodynamicists, controls engineers, systems engineers that are all required to design, develop, test, and prove that the systems meet the challenging requirements and our safety requirements to show that the vehicle meets its performance and safety goals, and the system meets its performance and safety goals. On top of that, of course, we have a great business team, some great interns, and really, we are ultimately running a business, and so we have to be able to communicate our ideas to the public and our customers and our supporters, and make sure that we're doing the right things. And if you look a little bit further down the line, I think we're a lot like the industry that Alex and Robert are creating, in that really not focused on displacing existing jobs, but creating a new transportation paradigm, which will actually create more jobs. So even though we don't have crew on board the aircraft, we do very much like the operations at Reliable Robotics have a ground support team that are monitoring multiple aircraft. We have a maintenance team that's to ensure the aircraft are in airworthy shape. And so it's I think an exciting opportunity in that there's lots of careers, and it's an exciting industry, and hopefully you'll find our products around the world.
What they said. You hit on all my talking points. I really don't know what I would add. Thanks, Jim.
Okay.
In addition to all of the technician and engineering jobs that we're adding here to Mountain View and the local area, when the product goes into service, it's going to fly itself, but the operations are not going to run themselves, and it's going to require a lot of people to maintain them. Aircraft need to be regularly inspected and maintained. The operations, as I mentioned, there's still a human being involved, and this needs to be a highly trained, certificated person, and that's going to be a non-trivial amount of employment to be able to run all of these systems.
Thank you.
Add something from a different angle, I guess, right? Being a government agency, it's not like we're expanding business per se. But I can talk about the changing workforce needs that we've had because of this kind of research. We've always had a lot of great aero engineers, great physicists, a lot of folks helping us do the aeronautical work. But we have seen a need for onboarding more civil servant software engineers, civil servant computer engineers, more than we've had in the past because of this move towards automation, a service-based system. So that's just one change we've kind of recognized in the past decade, that we've had a need to catch up, and how valuable it is for NASA to have a presence in Silicon Valley for the same reasons that they're talking about. Right, this is where the companies are, this is where the innovation is, and the fact that we have a presence here. We've been here a very, very long time, just down the road, but just keeping up with those changes is important.
Awesome. Thank you all. Next question, and just again, popcorn method, if somebody wants to tackle this one. What are your biggest challenges? And when I say that, we can so easily focus on the technology because you're talking about some really cool but technology that is growing in leaps and bounds of complexity of what we've dealt with in the past, perhaps. But are your challenges really technical? Maybe they are, but maybe there are more of the regulatory challenges, or maybe they're staffing because finding the right types of people to do this type of work. So just wondering what your challenges are and how you overcome them. And the reason I ask that is coming from the spacecraft world. We focused on the technology, but you got to be thinking ahead of what the challenges are to prevent problems from happening and bringing it down to stop work.
Yeah, maybe I'll start. And so what we're trying to do is ambitious and hard. So there are challenges everywhere. It's difficult to make an aircraft that can fly just on electricity. I mean, it's hard to make it light enough. It's hard to make the batteries energy dense enough. And so there are challenges in every field that we're trying to do, but it is doable. There are also challenges in the regulatory space and designing a vehicle that can meet regulatory requirements, working with our partners at the FAA and NASA to help define how you do this safely and reliably and effectively. And that is a big challenge. And I'm really so grateful to see people like Joey and to know that my colleagues at Reliable and Matternet are really working the airspace integration issues. So being able to operate these airplanes safely in today's airspace is a challenge, but it's an exciting one. I mean, I think if there weren't challenges, it wouldn't be as interesting of a job. So I'm in many ways grateful for them.
Yeah, similarly, we're trying to automate existing aircraft and integrate them into the airspace system that we have today. The military obviously has been flying autonomous aircraft for decades that we know of, unclassified. I think it probably goes back further. But we're trying to do this at scale in a civilian context where regular people can use autonomous aircraft. And that means you need to operate within the rules-based system that the FAA and Congress and others have created. And so, the biggest challenge for us has been since the beginning, mapping what we're doing into the existing regulatory framework. So what does that mean? Congress passes laws that creates the FAA and gives the FAA power to establish regulations, which are kind of quasi-laws, and then the FAA publishes regulations, and there's tens of thousands of pages of regulations that they've written that impact aviation, and then the FAA then publishes standards and other documents that describe how they expect you to meet all of these regulations where the regulations are ambiguous. And so we're almost like lawyers in a sense. We're not really lawyers. We're like engineers turned lawyers, and you get into the specific meaning of what do you mean by shall here in this statement? Is this a shall or is this a should? And then there are places where legitimately the regulations are insufficient. They don't cover what we're doing. And so we have to go to some other regulation that's more broad, and we have to make a case, present a case to the FAA that, okay, FAA, if we were you, this is what we would impose back on us. The FAA doesn't do any of this work for you. And it's not for the reason you don't think. It's because they actually very much believe in fair competition, and they don't want to be seen as playing kingmaker to a particular company. And so you have to do all of the work, and you have to present your case, and then it becomes a very technical and rational discussion. And I have tremendous respect for people in the FAA that do this work. It's very difficult. And it's also, there's a lot of risk involved because you're approving a private organization to go do something that could impact people in the general public. So that's really, I think, our biggest challenge and where we spend most of our time. As I mentioned, we've gotten through a lot of this now. We still have a few areas related to detect and avoid and the communication systems that we're working through, but fortunately, we've got most of it behind us now.
To jump in really quick, we have the FAA visiting us today where we're collaborating on some of these discussions. And we literally had a 1-hour discussion today about a shall versus a should versus a may.
It happens.
It was a full hour on that one sentence and that one word. And for us, we try and touch all the aspects they've been talking about, whether it's the materials, whether it's the actual vehicle design, whether it's electrification. What does someone need to use a wind tunnel? Does someone need to use one of our simulators at the base? So trying to support all of that's important. Those aren't the biggest challenges for us, right? We try and look ahead as much as we can. Again, just to reference Rob's chart in terms of looking ahead to the airspace, we saw the airspace as a key challenge. with companies tackling key things about how they want to design vehicles and working with the event how to certify them. We help where we can, but really focusing a bit on that airspace integration to make sure that they can fly when they're ready. Because again, no one wants to get to that point where you have this certified vehicle, but no way to access the airspace. That would be a situation we want to avoid. So we work hard on that. I'm not going to say it's the hardest problem, but it is a focus of ours, and it's one that gets overlooked, I think, when folks see the big, cool, shiny vehicle, right? We want to make sure it can fly.
Yeah.
Yeah, and we do have a certified vehicle that we, can use where we wanted to use it. So yeah, sometimes it does come down to that. I think I would add maybe that for us, really a key, like all of this combined, what really is a challenge is the uncertainty around it, so that we are not able to plan when we will have some of these rules figured out and these shall and should discussions sorted out. And that uncertainty for business is very, very difficult to manage.
All right, thank you all. So let's have a round of applause for our speakers. Thank you. And now I'd like to open it up for about 15 minutes of Q&A from the audience. We don't have a microphone to pass around, so please speak loudly, and whoever answers it, please repeat the question so everybody can hear.
I'm Dan Shane. I live just down the road from NASA Ames. I want to ask you a two-part question. One is, do you guys employ environmental professionals in the industry, in the unmanned airspace industry?
Our company, no. We have safety engineers that that do deal with environmental protection issues, but we're a relatively small company. We haven't gotten to a scale where we've needed to have full-time specialists.
Well, my thinking was that, and this could be a really good sales pitch for you guys. You know that fossil fuels has a lot of downsides. In fact, interstate commerce may be threatened soon by lack of fuel, the additives that they put in the fuel to make it clean, burn clean, okay, which are supplied by Russia and China and so forth. So there's a lot of things happening there, and environmental sustainability, climate change, all these things. How does that fit into your industry? Do you think about it? Do you use it as an argument for unmanned airspace deliveries and things like that?
Yeah, maybe Dan, I can jump in. So to repeat your question, I believe you're asking like how does sustainability and environmental issues fit into our workforce and our communication strategy? For us at Wisk, we really do care about the world, and I personally care about the world. I have 3 kids, and I want to see them grow up in a nice world. And we do have a sustainability team who's looking at our footprint, environmental and social, and so on and so forth. And we think really hard about all the components that go into our aircraft and our battery systems. And as an example, the aircraft has 0 emissions, but you also have to think of the life cycle of the battery. Eventually, the battery ages out, and we're working with other partners to look at secondary markets for the batteries, like energy storage, and also battery recyclers to make sure that we can recover the components that go into our cells. So it is something that we take seriously and value. We really want to provide a great service to our customers and do so sustainably. But it's a challenge, and it does require focus, and you're right to bring it up, especially for the younger members of our team. Understandably, it matters to them, and it matters to us.
Yeah, I would add to that as well, that like for us, maybe you remember one of the first slides of mine where really we see a huge problem in in moving more and more vehicles onto the road to do more and more deliveries, more and more small goods that need to be delivered by big vehicles right now. And we really see an opportunity here for this new technology to make it a big change.
I know it wasn't directed at me per se, but NASA does have a large portfolio of research into sustainable aviation, electrification, sustainable aviation fuels. So we have a large portfolio of that. And a lot of our metrics we've tuned towards being able to present the impact or the benefit to moving to a certain technology. So a lot of that does happen in our portfolio, kind of agency-wide.
Hey, Jim. I noticed in the aircraft, there's only safety belts, there's no airbags. What is the fatality rate if you have a direct impact in air?
Yeah, so I'll repeat the question. I think it was directed at myself. So the question was, what is the fatality rate and what sort of safety systems are in the cabin? So again, we take safety very seriously. So at Wisk, we're designing the vehicle and its systems to transport category aircraft standards. That means that the system by design is targeted at 1 failure per 10 to the 9 flight hours, so extremely safe, much safer than automobiles. And we're largely leveraging existing regulations to design the vehicle to achieve those impressive safety levels. There's a reason why your Southwest flight is as safe as it is, and it's because of a lot of hard work goes into it. So just as an example, in the cabin systems, aircraft features seats, and the seats are helicopter seats, which means that they actually have a vertical stroking mechanism in the event of a crash that absorbs the impact. We also make sure that the landing gear systems, as an example, are designed to take an impact, and we do drop testing to show that. We do tests on the battery systems. So as an example, we're required to take our battery up 50 feet and drop it and show that it survives the impact. So it takes a lot of work, and to be honest, a lot of money to be able to demonstrate and prove that these systems are reliable and robust. And the regulatory process is painful and difficult, but it's been a proven success. Aviation has a remarkable safety record, and we're leveraging those processes and tools and people to really bring a great service that is safe. And so, yeah, so the features you find in any commercial helicopter or commercial airplane will have in our vehicle.
So I want to be a aeronautical engineer. So what would be advice for me now to get there?
Were you able to hear that all right?
How to get to become an aeronautical engineer? Well, I mean, first of all, I think it just takes a lot of dedication. So if you're really into aeronautics and really would love to work in that field, just stay on it and really stay involved in the area. And then you need to go through school, and then there's great schools around the area here, and also anywhere in the United States, really, to really get you to that profession and work in that amazing field like we all did here. So it's absolutely achievable.
I would say, why wait? I mean, you can do it now. There's so much available to youth now that I didn't have when I was a kid. I mean, I had to play with paper airplanes, and now you can build quadcopters and drones on your own using parts that you buy relatively inexpensively on the internet. Yeah, you can get started on this right now.
Especially with small drones nowadays, very easy to get started.
I'd like to add to that real quick. So there's a lot of people with various backgrounds here today. When we're done and we do networks, please go talk to that young man. Share with him what you do. Share with him why you love it, and help him, plan his future to do great things. Thank you for the question.
Yeah, and maybe if I may, you're already doing great. I mean, you're here. You have a family member who took you here. That's pretty darn amazing. And you asked an excellent question. So, thank you, and thanks to your mom or parent who brought you here. That's awesome. And yeah, being an aeronautical engineer is a lot of fun. It's worth it. So do your best, try things out. Don't be afraid to break stuff. Yeah, I didn't set my house on fire as a kid, but I came pretty close a couple times.
Do it outside. Go outside.
Yeah, go outside. Do it safely, but have fun.
Thank you. So as someone who isn't a technical person, I'm not an engineer, I'm looking at all this and wondering, okay, so there's not a pilot in there. How do you address sort of concerns like the recent CrowdStrike situation or just the general vulnerabilities we know about our GPS satellites, aging infrastructure, for the civilian people, what kind of arguments are you making in terms of how safe it is, how susceptible it is to some of these, structural, environmental, technical, political, thank you, Mike, political issues that might come up. Thanks.
I know that you guys will have a lot of good answers for this, but the first thing I'll just point out is that CrowdStrike thing was intense, right? But at the same time, they made the decisions to keep the system safe when that problem occurred. So it's not like they tried to push through it, let's try and fly anyway when we're not sure about the systems. So you'll see that's one of those safety mechanisms. It may be impactful to folks getting delayed or canceled or not getting off the ground, but all those decisions are made to keep the flying public and the public at large safe, right? So safety is always paramount, and there's contingencies in place for when systems are not available or they go down and they flip into those contingency modes. Those contingencies will look different in these use cases, but that philosophy kind of remains the same. So I just wanted to kind of point that out.
Okay, 2 more questions from the audience.
Yeah, hi. I just want to preface that I started my career working at Ames, so I'm kind of liking all this stuff, very geeky about it, thinks it's wonderful. But the thought that kept going through my mind was, do we have to worry about kind of our airspace essentially being captured by sort of commercial operations, that a kid in the future will not be able to fly his kite or his quadcopter or things like that? Because to make it safe, you have to control it, and we can't just have us, pedestrians up in the sky. So how do we balance that?
Well, we've already made steps with the remote ID rules that passed. There's equipment that need to be put inside most every drone in the United States now so that it can be identified and tracked. I think the way we do this, I was talking about this a little bit before, is, we encourage folks that are developing airspace management tools and technologies to keep doing so, and then run it through standards processes with the FAA to ensure that everyone has equitable access to the air. I believe we can create a future where a hobbyist can build a drone and safely fly, and a Matternet drone can deliver within X number of meters from it. I think this is solvable. We have the technology, we can do it. We just need to keep encouraging this work, and that's why I said you need to be writing members of Congress to express your interest in this.
And I think we do see that our FAA partners, the stakeholders we talk to, ourselves personally at NASA, we do want to keep the airspace accessible to folks to use, right? So there's no appetite, I think, to say, okay, let's just carve all this out. These guys can do deliveries there and no one else can go in. Like that's a non-starter, and I think all the stakeholders at the table kind of agree to that. So the solutions exist. A lot of it is consensus building, standards making, public outreach to make sure folks know how the airspace is going to be used. But just know that behind the scenes and as we advocate for airspace use, it's never exclusionary. It's like, how can we get everyone to use the airspace in the way they want and need to in a safe way? And the flip side of that is, we can't necessarily rely on how we've always done things, because now that limits the new airspace users. So it is a balancing act, and it's a consensus building, and that's part of the reason some of these things take a very long time to actually get operational in the airspace, because we have to take in all those considerations. And a lot of kudos to the FAA for managing that process and being aware and sensitive to it. So it's an ongoing process for sure.
What do you think are some of the most impactful things unmanned aircraft can unlock? So Robert, you showed a high-level roadmap to the fully autonomous flying future, and you also mentioned again how we should write to our congresspeople and make this more top of mind for them to help expedite it, this effort. Why should more people in our community care about this? So in other words, what are some unique but meaningful problems only the autonomous aircraft sector can help us solve, to solve for our community and for the world?
Can I take this? Aviation is so beautiful. I love it. And I think we take for granted, most of us are now born post the jet age, and we just take it for granted that you can pull out your phone and you can buy a plane ticket to go someplace else. But the number of places where you can do that is shrinking. because we don't have the resources to be, the human resources to be able to sustain a large, healthy, vibrant aviation system. Autonomy is going to allow us to explode the number of aircraft that are operating in the skies. You'll be able to fly by air from, maybe perhaps one day the roof of this building to the roof of a building in downtown San Francisco, and think about like how amazing that will be, or get a package delivered to your home like instantaneously. For me personally, it means a lot because I have family that lives in more rural parts of the United States, Southern Oregon specifically. There's no commercial air travel to get there, and it's 10 hours by car, and it burns me up that for me to go home and visit family, this is like one day out of my life to go up there to see them, and then one day to get back. But there's runways, right? Like literally 5 minutes from their house. And I live 10 minutes from Palo Alto. If there were only an autonomous aircraft, then I could go to Palo Alto Airport, catch a flight. I could be up there in 2 to 3 hours. The time savings and freedom that would give me and my family. Through autonomy, we're also going to be driving down the cost. Through electrification, we're going to be reducing the environmental footprint. Mobility is going to radically change here over the next century, and I think we're going to take it for granted. AI is great, but I think the thing that is really going to impact the world over the next century is autonomous aircraft. That's why you should care about it.
Okay, I think we should wrap
Okay.
up. That was great. Some of the presenters will be able to network if they don't have to take off for another event. I'd like to thank each and every one of our panel members. And for those of you that didn't get to ask your questions, hopefully you will be able to interact with at least some of the panel members for the next half hour before we get kicked out of this beautiful place. Thank you to the Chamber of Commerce. Thank you for Mayor Showalter for kicking us off. And thank you for the Center for Performing Arts and KMVT for filming this so that the other people can enjoy this later. So big round of applause for our panel members. Thank you.